Anyway, we're going to talk about a little bit of intro to the mole. I know we talked a little bit about it in class today. So we should already know, okay, when we're talking about a mole, okay, we're talking about a chemist measurement. Okay, so we're not speaking about the mole on your face or, this mole that's in the ground. Okay, we are talking about what a real mole is in chemistry. It's a measurement. Okay, so we use it to describe amounts of atoms, molecules, or particles, for example. That big monstrous number that you know is 6.022 times 10 to the 23rd, or 23 zeros, if you will, which I'm sure you don't want to write every time, so that's why I ask you to please write it in scientific notation, 6.02 times 10 to the 23rd. Okay, now remember, since it is a measurement amount, it's similar to other measurement amounts. 1 dozen, for example, okay, 12. In this case, whenever you go to the grocery store, you know that it's for every dozen eggs, you're getting, you may not know this one, that's actually got 50 pennies in it. 1 ream of paper, remember we talked about that big thick clump, is 500 total sheets. A baker's dozen, that contains 13, because who wouldn't want an extra pastry? Okay. Then we have a couple, 2, the most famous ones, of course, being Brad and Angelina, so a couple, 2. Okay, and then a mole is 6.022 times 10 to the 23rd particles. So a mole of something is a heck of a lot more than anything else. So here's my mole, and I put them in a cup, so you know that, or a beaker, so you know that 6.02 times 10 to the 23rd is how many particles are in 1 mole for the chemist measurement. Okay, so what is a mole in science? It's different for different elements. Okay, so 1 mole of hydrogen is equal to its molar mass in grams. Okay, so if we look at hydrogen on the periodic table, we know that it weighs about 1. A mole of carbon, when we look at carbon, we ask how that is. It's the weight of carbon, which is 12.01, or in this case, I just rounded to 12. Okay, a mole of neon, if you go to your periodic table, you look, what's the mass of neon? It's 20.2. So how do you figure out what 1 mole is? You're simply going to use the atomic mass of the element on the periodic table. So let's try some calculating of molar masses. Okay, so for example, we have the sodium chloride, we have NaCl. But I want you to tell me what the whole molar masses of that substance. So the first thing I'm going to do is my atom count like I'm used to. Okay, so I have Na, I have clearly 1 of those. I'm going to multiply it by the weight that it's on the periodic table, which is 23. Okay, so 1 times 23 is 23. Next I'm going to look at chlorine, which is Cl. Go to the periodic table, I see that it weighs 35.5, so that I have 35.5. So my total molar mass is going to be adding my Na plus my Cl to give me a molar mass for NaCl of 58.5 grams per mole. So for every 1 mole of NaCl, it weighs 58.5 grams. Okay, now remember that this is different for different substances. Okay, so we'll try another one, H2O. So now in this case, when I look, if I'm looking at hydrogen, how many hydrogens do I have? 2, exactly. So I times 2, because that's how many I have. I multiply it by the weight of what is on the periodic table, which is equal to 2. So I have a total of 2 grams for hydrogen. Then I have oxygen. I only have 1 of those. The weight on the periodic table is 16. So I have 16. Now, in order to get the total molar mass, I'm going to do like I did with NaCl. I am going to add them all up. So 2.02 plus 16 equals 18.0 grams. Now, I just cut off the 2 here. We're going to round just to 1 decimal place to make it nice and easy. Okay? So then when I write it, remember, I'm writing 18 grams per moles. That's like I would say the same when I say grams per moles, it's just like you saying there's 12 eggs per every dozen. Okay, so that slash means per. Okay, so here's a couple more. We got BaCl2. Notice that I have 1 barium, so I multiply it by its weight, which is 137.3. That's from the periodic table. Chlorine, again, is 35.5, but this time I have 2 of them, so I multiply it by that. I got 71, for a grand total for BaCl being 208.3 grams per every 1 mole. Now, if I wanted to know what 2 moles of this substance is, I would simply just multiply the weight by 2, because I'm looking for the entire compound. Okay? Maybe one more that's a little bit harder is H3PO4. First I got to do my atom count like we've been doing. So I have 3 hydrogens, each of them weighing 1 for a grand total of 3. I have 1 phosphorus, each of them weighing 31 for a grand total of 31. I have 4 oxygens. Go to the periodic table, it's 16, and that's equal to 64. And then in order to find out the molar mass of the entire compound, I simply add them all up. And in this case, H3PO4 is equal to 98.0 grams. Remember, this slash sign again means per mole.